The population of Nigeria was about 155 million in 2012, and the exponential growth rate was 1.9% per year. In Part A, we're asked to write an exponential function describing the population of Nigeria. So the population then will be our starting population, which is 155 million, e to the our growth rate, which I have to write as a decimal, so that would be 0.019 times the number of years. So P is in millions of people, and then T will be the number of years after our starting year, which is 2012. So I'll say T years after 2012. Now in Part B, they want me to use my model to find the population in 2016 and in 2050. So starting with 2016, then the T that I'm going to use, because T is the number of years after 2012, is going to be 4, because this is 4 years after 2012. And when I get to 2050, that's 38 years after 2012. So those will be my T values. So in the first one, I have P then is going to be 155 using my model, E to the 0.019, and this is being multiplied by 4. So this will give me approximately a population of 167.2 million. Now remember, that was in 2016. And in the second one here, we'll do 155. Again, this is my model. E to the 0.019. That was the growth rate. And this time we'll use T is 38. So this will give me an approximate population of 319.1 million. And that was in the year 2050. Now Part C wants to know when will the population be 200 million. So using our model, this time we know P. So 200, and it's already in millions, needs to equal our model, which was 155 e to the 0.019, but this time they want to know when, so our variable is t. So this is what I have to solve. First step will be to try to isolate my exponential. So I have to divide both sides by 155. And I'm just going to leave it that way. I'm not going to reduce my fraction. I'm not going to turn it into a decimal. I just want to keep it exact. But this will leave me with e to the 0.019t. Now, next, to get the t out of this exponential, since my base is e, I'll go ahead and take the natural log of both sides of my equation. And once again, I'm not going to type this in my calculator until t is all by itself. So natural log of 200 over 155, I'll just leave that exact for now, equals, these will cancel, and I'll end up with 0.019t. So then the final step would be divide both sides by 0.019. Now I'm going to be ready to type it in my calculator, because I have all the numbers on this side and t is left alone here. So I end up with t is approximately, typing this in, we get about 13.4, so which is about 13. So then, remember, it's aligned to be the number of years after 2012, so I have to take 2012 and add 13 to it, which will give me 2025. So the population will be about 200 million in the year 2025. Part D wants to know, what is the doubling time? Meaning, when will the population double? So we could start with the 155 million here. E to the 0.019t, and know that it's going to double, so this will become 310. But if you notice, the very first step, if I divide both sides by 155, what's going to happen to me is I'm going to get 2 equals 1 e to the 0.019t. So doubling time just means every 1 becomes 2. So I could have started right here. Now, I already have my exponential isolated now, so I'll go ahead and take the natural log of both sides, giving me the natural log of 2 equals, this will cancel, giving me 0.019t. And then finally, dividing by 0.019, 0.019, typing this part in my calculator gives me about 36.5. So that's what t is. So the doubling time then is approximately 36.5 years.